Einstein's theory of special relativity. Sounds scary, doesn't it? Well, it doesn't have to be. Hi, my name's Kristen, and in this video I will help you learn a little bit more about special relativity. First of all, what is the theory of special relativity? Well, this was developed by Albert Einstein in 1905, and it's a physical theory regarding the relationship between space and time. Special relativity focuses on objects at constant velocity, which is the same speed and direction. Two important parts about special relativity are time dilation and length contraction, which we'll go over a little bit later. On the other hand, general relativity focuses on objects that are accelerating, which is speeding up or slowing down, and takes into account the force of gravity. General relativity particularly influences the bending of spacetime due to large-scale objects such as planets. Now that you know about how special and general relativity are different from each other, let's go back to just talking about special relativity. There are two main postulates that this theory is based on. The first one is that the laws of physics are the same in all inertial frames of reference. Inertial means constant velocity, and frame means the viewpoint at a certain velocity. The second postulate is that the speed of light c is a constant that is independent of the relative motion of the source. No matter how fast an object is traveling, the speed of light will always remain constant at 300 million meters per second, or 3 times 10 to the 8th. Now, let's move on to the two main parts of special relativity, time dilation and length contraction. Time dilation is when an object is moving very close to the speed of light, time will begin to move at a slower rate. This concept can be easily understood by looking at a stationary clock with a laser attached to it and a mirror at the top. If the laser was programmed to shoot out every 5 seconds in relation to the clock, then the laser would simply come up and down since it's traveling at the speed of light. Time dilation actually occurs when you start to move the whole system. This is because the faster the clock moves to the speed of light, the longer the pathway is that the laser needs to take, thus taking a longer amount of time for the laser to hit the mirror and come back to the clock. Length contraction is when an object is moving very close to the speed of light. An outside view of the object will appear compressed in the direction it is traveling. In contrast, when a person is inside the moving object, everything that it moves past will appear stretched out. Let's say that a stationary stick measures 5 meters, and the person looking at it also knows that it's 5 meters. Well, as soon as you start moving the stick at very high speeds, the harder it is to measure it. Since it's moving close to the speed of light, when you first measure the beginning of the stick and then the end of the stick to find its length, the stick will have traveled some distance in between that time. So, in order to get a proper reading, you need to be able to bring the end of the stick back in time in order to be properly matched up with the beginning of the stick at the same time, thus producing a stick that appears shorter. You see, learning about special relativity wasn't that hard, right? I hope now you know a little bit more about time dilation and length contraction. Thank you for watching!